All right, we're getting late in these tutorials and things are getting a little bit crazier. Again, I don't really know where I'm going to go with this particular video, but I do know what I want to talk about. We're going to talk about variables, constants, and macros when it comes to scripting. I'm going to show you our built-in script editor, and we're going to talk a little bit about what a variable is, what a constant is, what a macro is, and how to use them and when to use them for those of you who want to start really getting into some advanced functionality and making NESmaker your own and making, your games. So let's take a look first at, we did look at some scripts when we were editing the scripts. What we didn't look at defined scripts. We didn't look at that folder. Well, let's click on that. Oh, well, this is kind of neat. Let's talk about what we're looking at here. These scripts here are all the scripts that you have defined here. You can actually make your own definitions for scripts. If you wanted to include new scripts into code, you can actually add script defines. You give it a name, whatever you want to call it, doesn't matter. You give it a define, and this is whatever you want to define it as. Usually I start my defines with SC, like if I wrote my script, and then I'd write scr underscore my script, and I'd hit OK. And that now shows up at the bottom of the screen. And I can now tell it, okay, I want my script to run something. I want my script to run a blank, a simple reset, so we can actually test to see that it works. All right. Now I can go into a piece of code and I can include that somewhere. So for instance, I'm going to go right into the physics engine. And this is a built-in script editor, so you don't even necessarily have to go out to Notepad++. You can do a lot of stuff right here. This is the current physics that are running for this engine right here. So what I'm going to do is, as soon as the engine starts, I'm going to run, as soon as the physics engine starts, I'm going to include scr underscore my script. And what that's going to do is it's going to take everything that was in my scr my script, and it's going to stuff it right here. So it's going to do all the things in that script. And if I remember, I'm going to hit save. And if I remember right, what did my script do? My script was set to simple reset. And if I look at simple reset, what does simple reset do? It's if something is the player, it's going to reset. So eventually when it's checking collisions, it will be the player. In fact, my game's really not going to load because it's going to immediately see the player and it's going to get stuck in this reset. I might see a flash of the screen. Let's see if that works. And bam. So that's what's happening. It's just resetting over and over again. And it'll do that indefinitely because every time it gets to the collision script, it's reading this script define right here. So this is a placeholder. This is a placeholder for whatever I put here. So let's change that. This is kind of what we did before. Let's change that. Instead of a simple reset, I'm just going to make it a blank script. So now a blank script is being put here. It's as if I copied what was in a blank script and put it right here. And I'm going to save that. I didn't even make any changes. I just changed the define. I changed the what script that define was looking at. Now it'll run no problem because I set the script up. Perfect. Awesome. So you get the idea, hopefully, of how you can add script defines and put in your own custom script defines in places. Now, keep in mind, that does use up memory. So however long your script is, that's how much memory that you're using up. So eventually, you're going to keep adding scripts and you're going to get that dreaded assign banks value out of range error. If you ever see the assign banks value out of range error, it means that one of your banks overflowed and you have too much memory crammed into that space. And believe me, it happens fast. So eventually we're going to work on a system where you can actually check and see how much memory you have. For now, if you want to really see, you can load up a tool called NES Space Checker. This is another amazing Shiru tool. I can look at NESmaker and I could bring in my compiled game, and this shows me the data usage of all my banks. And the bank that I really want to look at is probably the 1F bank, and this is all the room that I have left in the static bank. A lot of these are allocated for different things. Like this is all screen data right here. So these are for the map 1, these are for map 2, and they control the graphics and the collision and the attribute data. And then there's banks for monsters and banks for the graphics that I've loaded, and banks that it looks like there's a lot of space here, but that's because this game doesn't have anything in it. I haven't really I've only made one tile set out of all the 18 tile sets, and I've only made one monster, you know. I haven't used any text. I haven't really loaded any music. So these start to fill up really fast. But where you're probably going to run into filling up with data, where you got to watch that is here. So just keep an eye on that meter. Another place, the overflow bank is 14. If you know what you're doing, you can see what scripts are loading into bank 14 and what scripts are loading into the program bank. That's more of an advanced feature, but just, you know, keep an eye on that right there as you're creating your own scripts and stuff like that. Okay, so that said, that's how we add a script. But let's jump back a little bit and talk, like I said, about this interface. Let's talk about scripts, macros, variables, and constants. All right. So variables are exactly what they sound like. Variables, if you do any kind of game development, you know what a variable is. I'll give you some examples of variable. Variables are anything that changes during a gameplay. For instance, how much health your character has. So in this game, we have a variable called my health, and that's what determines how much health you have. And it changes when you run into a monster, it goes down. When you collect a heart, it goes up. So it changes throughout the game. The player's exposition, that's a variable. What screen you're on is a variable. And there's a lot of things for nest development and assembly language that need very particular variables to be able to run, and pointer variables and all kinds of stuff like that. If you want to start writing your own variables, or if your engine that you're using doesn't need variables, I can actually go into script settings. Instead of having to wade through code to try and find where I'm setting up variables and stuff like that, we actually have set up your variables in here so you can do things with them. So let's take a look at my 0-page RAM. I've actually got all my 0-page variables loaded up here, and these are special variables. They're easier to address because they're all on the 0th page, so they only need one byte to determine where they are. So your pointers are almost always here. There's a bunch of others that are generally here. Our sound engine updates have to be in 0-page. And so if I wanted to add a new variable, I could go to add, and I could find it at the bottom, and I could name it my custom var. Okay. And it's going to take up 1 byte. This is just one single value of something. And I could even take notes. This variable will do nothing. Okay. So now I could take notes, and I could save these notes. This saves with the project. So I'm saving these notes for myself, and I can see what this variable is supposed to do if I ever forget. Oh yeah, like some of these, the text var, that edge trap flag. What does that do? I can't remember. I can leave notes to myself so I can remember later. I also have a readout that tells me how many bytes are used. Now this doesn't do you much good unless you know how many bytes each section is max. Generally for 0-page and overflow RAM, you want to keep it under 255 or less. If this number gets higher than that, you're going to start to run into problems because your memory is going to overflow into the next page where there's other data stored. If any of you remember playing around with the platform tutorial and music completely crashing your game, it's because we had more than 256 bytes worth of variable data, and it was overflowing into where the music was playing. So all kinds of chaos was happening when values were changing. And that's the horrible part about dealing with memory management. So, but I can create custom variables and use them in a game. And how would I go about using them? Well, without getting too deep into assembly data in general, assembly language in general, I could say, I'm going to load into the accumulator my custom var. And this is happening in the calculate ACC and speed script as well. Still, I can load in the accumulator my custom var, and I'm going to compare the value, compare it to 3. So now I'm saying, hey, check out that value that's inside this variable. Is it 3? I'm going to branch if equal, and I'll just put a little plus sign here. And down here, I'll put another plus sign. So basically what this is saying is, hey, check out that custom variable. Compare it to the number 3. Branch if equal to this little plus sign. So if my custom variable is equal to 3, branch to this little plus sign. This is what would happen if it is not equal to 3. Do this. And then something, something. I could even put dot include scr my script. So it only does the my script thing if that variable does not equal 3. And if it does equal 3, it skips it altogether and comes down to here. Awesome. So think about all the uses that you can have for this. Like, I want to check and see what animation state my player has. If my player's animation state is the 3rd animation state, that means he's attacking, and that means I can't be hurt maybe or something like that. So I skip the hurt script, and that's the kind of logic that goes into using assembly language to make a video game. It's not that far off from using any kind of programming language logic, but getting used to this whole branching system and stuff like that takes a little bit getting used to, even if you know programming. But the logic is actually really, really simple. So I encourage everyone to start learning this stuff. Definitely learn assembly language. If you want to make an awesome game, you're going to do it with assembly language. NESmaker is just going to be a tool that's going to get you started. So I encourage everyone to do that. But if you don't, this is basically how a variable can work. So let's talk a little bit. That's a little bit about variables. Let's talk about something that's probably going to be even more powerful for you, for those of you who don't want to deal with the logic, and that's constants. So what a constant is, basically, let's pretend for a second that I have a constant in this game for gravity. All right. Throughout the whole game, gravity, the gravity force is always the same amount of power throughout my entire game. And I know that it's going to be that way. And so what I'm going to do is I could just set it to a value. I could say gravity equals 4 at the beginning of the game, and it just stays that way. I never change it. Okay, so every time like a monster's in the air, it adds 4 to its Y direction, so it moves it down the screen. Now, let's say I'm working on that game, and there's 20 different references to where I have to update that number, and I can't remember where I put them all in all the scripts. Instead, what I'm going to do is I'm going to make a constant called gravity speed, and I made a low and a high variable for gravity speed. And instead of writing the number 4 in all those places, I'm going to write the term, update my Y position by constant gravity speed, this constant gravity speed. And whatever I set that constant gravity speed is just going to be substituted into there. So when the game compiles, if I had the number 4 written in there as gravity speed equals 4, then when the game was running, it would just input 4 into all those places where I wrote the word gravity speed. But then I'm like, oh man, I wish it was falling faster. So I come back and I change it to 6. And now it imports 6 into all those places. It removes the word gravity speed and puts 6 in all those places. So it looks like I fall faster. So this is a great one that you guys might want to mess with. Starting direction. This is a constant. Right now it's set to 2. And I made a note to show you what values were for what directions. So right now its starting direction is 2. So he starts facing to the right. All right. Now this is a constant that I created that somewhere in the script, it's when I load the object, it sets its direction as, doesn't set it to 2, it sets it to starting direction. And since it does that, right now, since starting direction is equal to 2, it puts the 2 in place. But if I were to change this to face left, I'm going to change it to 6. So now my starting direction is 6, which is left. And let's take a look if I were to test this game. I don't know when the last time I saved this script was. Hopefully I didn't mess that up. Right now it's unsaved. Okay. So I start the game facing left because I changed a constant. Now, a constant's not a variable. I can't change this throughout the game. This is something that I'm setting at the beginning of the game. But here's the best part about constants. They don't take up any memory. So you can literally just put lots of these custom defines in these constants and have like an infinite amount things that you can sort of tweak. So for instance, I have a constant for ladder speed. So my code for ladder checks to see how fast I should move up a ladder. If I'm moving too fast, I can just change these ladder speeds low and high, and think about this like minute hands and hour hand. So this goes 0 to 256 and this goes 0 to 256. When this goes over the line to 256, this goes up a number. That's how that works. So it's like when the clock gets around to 59, it goes the hour hand goes to the next number. Now it's 1 o'clock instead of 12:59. Anyway, so here's another one. Hide HUD. If I change hide HUD to 1 instead of 0, there's no HUD up here, and that's what I basically look in the script. I have it say, okay, look at hide HUD. If it's equal to 0, do this. If it's equal to 1, do this. Now I don't want to hide the HUD. So anyway, these are just some of the constants. And as we look into different modules for creating different games, we're going to look at how we use these constants for various things. For instance, to determine what sprite is the weapon, or which object is a prize block. What collision data does a breakable block change to? Like in Mario, when you hit a question block, it goes to a dead question block. But maybe you want it to go away completely, like you're breaking it, right? So you can set the different collision detection for after the prize block, like what happens when the prize block should go away. Is it solid or is it not solid? Anyway, so these are just some things to definitely know about. So that's when you're dealing with constants. That's what you're dealing with here. So the last thing we're going to talk about is macros, and we're actually going to create a custom macro real quick. This won't be in your version. We're going to create it right now, and I'm going to teach you how to do it. So what's great about our code editor versus working in Notepad++ is these are the current macros that exist in my game. Not all of these work for all modules, and in fact, some of them I think are no longer functioning at all because of the changes to the engine, and I just haven't gone through and removed the bad ones, but a lot of them do work. So what's fun about this is, let's say I want to, I don't want to do that. What could I do here? Let's see. Trying to think of something I could do. Okay. These are the top bounds. These are the current loaded bounds, right? And remember, we set the bounds to go to reset. So tile collision 1 is set to this solid thing, and this is going to be super weird. But let's say that when I hit this, I want to also, when I hit a solid object, this is probably going to just be like a siren, but when I hit a solid object, I want to play a sound, and I can see play a sound is one of the macros that exists. I'm going to just double click on play sound, and you can see it inserted it. But I'm not quite done yet because obviously I need some information. What sound do you want to play, Joe? Well, check this out. Once I've got my mouse on a macro, down at the bottom, it has some information. And if I scroll upwards, this shows me the macro. And in fact, it even shows me what the arguments it needs. Now, this is an outdated thing, but it does show me it needs an argument 1. In this case, it needs to know what song or what sound is it going to play. So the sound that I'm going to have it play is this one. If I go to sounds, and I go to music, I'm going to have to put this back in. I'm going to save that real quick. If I go to sound effects, when I hit the ground, the only sound that I have loaded is jumper. I wanted to play SND_jump. So if I go to my scripts, define scripts, and I went to tile collision 1, and I went to play sound. Let me pull this back over. Cool. Okay. The sound that I wanted to play is SND_jump, right? That's what I called it. And then jump pointed to the SFX jumper, right? Let's just make sure. SND jump. That's the constant for this sound, and the value of it is that. So now when I hit the ground, it should play that sound. Now I think it might just do that as I'm standing on the ground too. So this is going to be the most obnoxious sounding thing that we've ever heard, but yeah. So it's just playing it repeatedly. But you can see how I was able to add that macro really easy. Double click, look at the arguments. What does it need? Oh, it needs to know the song ID. Right. Okay, I get it. So let's take a look at just a couple more of those, just so we can sort of start to see how to read it. Now, some of these have detailed explanations, and some of them not so much. Some of them, are very complicated to read and stuff like that. But let's say I wanted to look at handling player hurt. Okay, so this kind of gives an explanation on handling player hurt. Actually, let's look at handle monster hurt, right? So this is kind of interesting because at one point, I added a value. So I'm adding a value to the variable my score. And then I'm updating the HUD with my score. So let's take a look at updating the HUD. Let's say I want to make it, and I don't know why I would do this, but let's say I want to make it so like my health would go up if I kill a monster. Okay, so I want to add value to another variable. So I would add value, and let's take a look at what add value needs. If I scroll up, it looks like there's 4 arguments. It needs to know, okay, argument 0, how many places does this value have? So like if it's an 8 value score, it would be 8. If it's like I was showing keys earlier, it only had 2 places. It was 00 or 01 or 02. So let's say it's 2 places, and the variable that I'm updating is my health. That's one of those HUD variables. How much do I want to actually add? Well, I just want to add 1 life, and to what place? So what I mean by place is 0000000. I don't even have to do that. If I think about places, 120, 230, there we go. So 1's place, 10's place, 100's place, 1,000's place, etc. You get the idea. What place? I just want to add that to 00, the first place, the 1's place. So if I did 1, if you could imagine every number moving over to the left 1 in the number. So this would be the 10's place, and this would be the 100's place, and this would be the 1,000's place, etc. So right now I'm going to add that value, and I also need to update it in the HUD. So I'm updating the HUD with my score, but I also need to update the HUD with my health. So if I go down to update HUD, and I could look at the macro update HUD, what does it needs? It needs to know the HUD variable to update. And it actually shows me the code that it's running. And there's that BNE and BEQ stuff that we talked about before, right? So I'm going to update HUD, and my HUD variable is HUD my health. So now it's going to update HUD my score, and it's going to update HUD my health. Awesome. So that's just an example of how I could, look at a script and add things that I want. And, there's going to be some of these that you're going to use sort of commonly, and some of these you're probably never going to use. So anyway, let me get rid of that and get rid of that. And I'm going to save it. And you'll start playing with these, and some of them will just tell you, oh, that broke. And okay, so don't use that one. But anyway, so hopefully that gives you an idea, a little bit about variables, a little bit about how to manipulate some scripts, a little bit about macros, a little bit about constants. I hope that's sort of a roadmap to starting to experiment and play around. And we're going to look at how to prevent yourself from totally screwing up NESmaker in one of the other tutorials about creating a custom module and backing up your script folder. When in doubt, jump back to my editing scripts example and make duplicates of scripts that you might want to change, and assign assign your scripts to that. So, go into your script settings when in doubt. And if I want to make my own physics routine, fine. Everything's so integral on physics routine, but if I want to make my own, I can go to File, Save As, and just put, my physics 1.0 custom and whatever, and put it in my own folder or whatever. And then I could point this to that one. And if I screw it up, I can always just jump back and point to the original one without screwing anything up at all. So yeah. Anyway, that's way too long for this video, so I'm going to stop it here, and we're also going to look at how to do special screens and how to create a custom module and back up your entire script folder to make sure that as we advance through versions, your games that you're working on never sort of lose sync with NESmaker. You can always continue to work on them.